From Microbe TV, this is Office Hours for Wednesday, the 19th of February, 2025. I'm Vincent Racaniello, and welcome to your viral corner of the internet. This is a place where we celebrate science, which is apparently not a thing that's being done at the higher levels in this country. But here you can find celebrated science, mostly virology, but other things as well. And that is how it will stay. So tell us where you are from while I'm introducing our moderators, and then we'll shout you out. So tonight, Les is here. Thank you so much for joining us. Steph SF is here. Tom Steinberg is here from Western Oregon. And that looks like our Vanity Nutrition just popped in. That is our moderator crew. Maybe others will come later, but it's a good number. Thank you for joining us. Thank you for keeping things civil. We really appreciate it. Let's see who's here. As you know, we talked about Dixon last week. Everyone knows he passed, but there is a nice obituary in the New York Times. And Les has the link there, so you can check it out. It really highlights his role in indoor farming, which is, I think, the way it should be. He did something really different there and published a couple of books about it. And so I think it's great that the obituary recognizes that for him. Brian is in Montreal, minus 12, 70 centimeters of snow on the ground. Well, I'll be in Montreal in July, and thank goodness there will not be 70 centimeters of snow on the ground. Here in New Jersey, it went down as low as minus 10 Celsius. So still very, very cold here in the Northeast. Sub-zero temperatures most of the day, and of course at night as well. I'm not enjoying it at all. I'm not enjoying the cold weather this winter. It hurts. I dress very warmly, but I spend a lot of time running around New York, and it's bloody cold. I don't like it. Wayne, from Urbana, Illinois, minus 13C. There you go. Minus 13C. It's a problem. Abdur Rahman is in Brooklyn, minus 2C. Welcome, Abdur. Really nice to see you. Patricia is in Chile, Massachusetts. Dagfin is in Oslo, where it's minus 8 at 2 a.m. Bravo, Dagfin, for staying up late to do this. You know, I was in Helsinki. Well, I was in Finland and Sweden last summer. And my last night was in Helsinki. I was staying in a hotel, and then we did a TWIV. So I don't know why. I ended up finishing really late. So I decided just to stay up all night. Because I had to leave like 5 for the airport. So I just stayed up, and of course, at the last minute, I nodded off, and just some noise in the computer woke me up, and I was okay. We did a podcast, and that brought the hour late. Lise is in Columbus, where it's very cold. Gallbladder 8. Carnival time in South Louisiana. Happy Mardi Gras. Yeah, that's right. It's February. It's Mardi Gras. Ah, it must be so nice and warm there. Vic is in Grand Rapids, Michigan. Costella is in Ohio. I know that much. Vic says it's minus 10 at 8 p.m. in Grand Rapids. Carol, our favorite nephrologist, is in Bakersfield, California, 70F21C. Now that is nice weather. Oh my gosh. MN is outside of DC. Kang is in Chicago, a -11C. Jonathan is in Encinitas, 16C. So that's nice. That's very comfortable. Angry Penguin is north of Toronto, -10 and done with shoveling snow. Yeah. Betty K is in Washington Heights. Nice to see you, Betty K. John is in Minneapolis, -14C. That's pretty cold. It's always colder somewhere else. Will is in Changsha, China. Ni hao. Nice to see you, Will. Patty's in Massachusetts. Ubalubi is in La Petite Roche, Arkansas, 7 p.m. Joseph, Southern Ontario. Pete is in London, 7 to 8 centigrade. Yeah, leak in a water main. That's always good to come home to that. Dean is in Wisconsin, where it's 0 Fahrenheit. Tryon is in Romania. Rita is in southwest Idaho. Patricia in D.C., having a real winter. Maureen is in northeast Ohio. Michael Schmidt is here. 4 degrees. Not so Chamber of Commerce, Michael. You have to do better than that. You have to make us jealous of your warm weather. Jan is in Tucson, where it's 24C. Cheryl is in southern Ontario, -9C. Look at these variations in the temperature from really cold to nice and warm. Nice and warm. Howdy, Jeff. Good to see you. Elizabeth is in West Virginia. Mike is in Seattle, 47F. That's not bad. Chris and Lisa are in Montreal, -16C. And H. Zhu is in Austin, Texas, -2 Celsius. Pretty cold for Austin, right? Otto from Cincinnati says hello. Yeah, give us a thumbs up. We have 124 viewers and 48 thumbs up. Hit the thumbs up button so that maybe we attract more people and teach them how cool science is, because apparently much of this country doesn't think it's a big deal, and they're good with administration trashing science, which is what they're doing. Don't make no what? Something about it. I forgot what the phrase is. No doubt about it. They're trashing it. I think the idea is to reorganize it and have it done by the states, right? But that's an ideology that you think you don't like big government. But so you're going to break all the big government to redo it? That's so stupid. It's just dumb and shows, you have your ideology, but you're just stupid to do that. You think you know everything, right? The authors of the 2025 plan, they think they know everything, and they know zero, actually. Okay, back to introducing us. Laura is in Washington, Pennsylvania, -9C and dark. Eto, 2001, Cincinnati, 18F. Environmental is upstate New York, where it is 11F. Silent Runner is in Wichita, 5F. Shoveled snow for an hour this morning. Sorry about that. Dean points out that Dixon's indoor gardening expertise would have been useful in the strategy for colonizing Mars, for sure. For sure. A lot of people with that expertise now, thanks to him. Julie S. is in north central PA, 25 Fahrenheit. Hello, Cheryl from Santa Rosa, 62F. Jealousy. John is in the far north of Thailand with his bottle of Listerine. And Tryon tells us it's -8C in the county in Romania where he is. Maureen says Lake Erie is 90% frozen, so hopefully less lake effect snow. Hat is in LA where it's 64F. And look at that. H. Sue said, convinced my band to change our practice day to Monday so I won't miss office hours. That's very nice. What kind of band do you have? Is it a rock band or a marching band or something else? Tell us. I'm really curious what kind of band you're in. Hello, Dan from Cambridge 7C at 1 a.m. Questella tells us that the East Antarctic Plateau is minus 43 to minus 65. Yeah, good riddance. I'm not going there. Don't worry. I'm not going to go. It's too cold. I would just stay in warm weather, but here in the Northeast, we got some months of cold weather. There's nothing you can do. I ain't going anywhere. Albert is in Mexico. ADF. Oh my gosh, that's so nice. Continulkin. Cool. I never heard of that. SRR 64F in Paso Robles, where there's very, very fine vineyards. Lovely. Fred is in Southeast Pennsylvania, 19F. Shriha. Hello. Welcome, Shriha, wherever you are. It looks like you got a big city behind you. Maybe it's New York. Admin likes science. He wants IVF. Greater Philly area, -6, Shrisha. Thank you very much. Vic loves to shovel. I don't. I never did, but I had to. Hello, Jill from Wilmington, Delaware, where it is 24F. Carol tells us that there's interesting research by Amy Prohl, data suggesting that patients with long COVID do not fully clear virus. It may persist or provokes the immune system. That's possible. It need not replicate, but virus can persist and still provoke the immune system. By the way, there's a long COVID center at Columbia that Daniel is affiliated with, and he told us on Clinical Update recently that the CDC has informed them they will no longer be able to support the center, which they had been doing to a certain extent because of budget cuts. Unthought of. I mean, no one has considered the consequences. They have this stupid goal that they want to achieve, and they don't consider the consequences of what they're going to do. This is inexcusable. Eliza, -7 in southern Ontario. Tim Smith, 9C in Portland, Oregon. Tom Steinberg quotes Mark Twain, in 1845, when I was 10 years old, there was an epidemic of measles, and it made a most alarming slaughter among the little people. That's right. It can kill, and more parents are not vaccinating their kids because they think the vaccine causes autism because of shamans like RFK Jr. keep promoting that, and other people as well. And no, it doesn't. It does not. The MMR vaccine is really quite safe and does a great job of preventing measles, mumps, and rubella. No autism, none whatsoever. So parents, why are you listening to the anti-vaxxers? Unbelievable. Purely positive, -4 in Maryland. Near Cohen, White Plains, it's 24. Lori is in Charlottesville, Virginia, 20F and snow. Frank, good evening, Frank. Nice to see you. Mark Twain continued, there was a funeral almost daily, and the mothers of the town were nearly demented with fright. Unfortunately, Tom, that's where we're going to have to get before people come to their senses and start vaccinating their kids. We're going to have huge outbreaks, which will take some time to build up. and parents are going to get afraid, right? Bionerd Genevieve 19F in Orono, Maine. Gang says cuts to the science budget destroy the promise of future progress. We should remember that Abraham Lincoln signed legislation establishing the National Academy of Sciences to advise the government. I mean, we have a long history of developing science in the U.S., obviously, and we've built wonderful institutions that are the envy of the world. People come here to the U.S. to train because the science here is amazing, and you can pursue your curiosity here more so than in any other country. And now it seems we're just going to throw it all away. Break it for no good reason, just to satisfy your ideology. And I think I've heard that the idea is that they're going to give boxes of money to each state, and then the states can figure out who to give it to. Okay, that's your idea. I get it, but why? You got a system in place that works. Yeah, they claim it's wasteful and this and corrupt and this and that. It's all lies. It's lies. There's waste everywhere, of course, but it's not so wasteful that you have to bring it to a halt. Besides the indirect costs being cut to 15%, which is a hardship on most universities, they've just stopped paying out NIH grant money. And so this is money that's been promised to a lot of people, and they've made plans based on it. It's not very fair. Where's your compassion? You have zero compassion, right? And why doesn't 50% of the U.S. realize that? They have no compassion either? Purely Positive is new here. Welcome, Purely Positive. Hope you enjoy it. Hoxterful is in Cape Coral, Florida, where it's 70 degrees. Wow, that's very pleasant. This is very, very pleasant. Jem is in Hampton, Virginia, where it's 28F with several inches of snow. Abdur says, you are very generous, Vincent. They know exactly what they are doing, destroy the authority of anything that can challenge them, including science, and make public ventures lose to get privatized. Yeah, I understand that that's part of their strategy. I don't know why. Why would you do that? You want to go down as the president that destroyed science in the U.S.? Seems like a bad legacy, right? It's very sad. I have trouble these days keeping my head up. Perhaps the parents will believe Mark Twain more than the modern scientists. Junebug is in Virginia. Welcome. Les tells us that's from the autobiography of Mark Twain, chapter 15. EH's talent is in Lehigh Valley, Pennsylvania. And Angela from Twiv is here. Minus 13, 80 centimeters of snow. Hello, Angela. Nice to see you. Atos says, last time I heard whooping cough was in the 60s, but have heard twice in the last 2 years. Yeah, there are outbreaks for sure. I have specialist says, I remember having measles, and I can't imagine anyone putting their child through such misery. Gail is in Chapel Hill, North Carolina, 25F and snowing. John says, as long as people can make money or gain power with anti-vax messaging, there will always be some individuals to take advantage of it, despite the human cost. Yeah, that's correct. They don't care about the human cost. They care to enrich themselves. Money means more to them than anything else. Money and power. Yeah. Carol says we have a constitutional crisis. Yes, when the executive branch doesn't abide by the law, right? This is a real problem. And the Congress, which is supposed to check the executive branch, it does nothing because slightly more than half are of the same party who will do anything. I got a warning from someone saying, you're a nonprofit. You can't talk about politics. A nonprofit cannot donate money to political causes. That's the law. You talk about whatever the frig you want. Okay, Tryon. You talk a lot about cryoagglutinins. What are they? These are antibodies that do something at low temperatures. Tell us what it is, because I don't really understand. Hello, Dr. Bro Shropshire from Birmingham, 32 degrees. Won't get to Mardi Gras for a couple of weeks. Hello, Sabrina. It's a good idea to check MMR titers in case you may need a boost. Good to check at these times and if you're traveling to certain places. Area ozone is taking it day by day here in Asheville, where it's 32F. Jefferson Space is in Miami. Hello. Angry Penguin wants an example of a virus that only infects fungi. Oh, there are many. So chestnut blight virus is a virus that infects the fungus that causes chestnut blight, and it modulates its virulence. Then there is a fungus that infects grasses that grow around hot springs and allows them to be thermotolerant. And that fungus has a virus in it. Curvularia protuberata is the fungus, and the virus is called Curvularia protuberata virus. So Nevitz says the EIS is being let go, but I heard this morning that they are not being let go, which would be smart not to let them go because they're a highly talented epidemiology group, among which is one of my former PhD students, and they do very good things. You get rid of them, you're going to have big trouble. ZZ Captain, 3 degrees F is in Fort Riley, Junction City, Kansas. Vic wants to know about Amy's job. I cannot talk to you about Amy's job for obvious reasons. I'm sorry. John wants to know, why does mRNA have a half-life so short? Well, all mRNAs don't have short half-lives. It depends on the mRNA. Okay, so there are signals in the 3' untranslated region, right? So where the protein coding region ends, there's some bases, and then there's a poly A tail. There are sequences there that control turnover by a system of nucleases in the cell that degrade RNAs, because you don't need mRNAs to be around forever, right? So you give them the time that they need. It can be minutes, it can be hours, it could be days, the half-life. It depends on the mRNA and what it's used for, but they're not all short. No. If you're going to design an mRNA vaccine, you could make the half-life relatively short to ensure that it doesn't stick around, for example. EHS Talent remembers being in a hospital in Switzerland with measles, feeling like I was gonna die. I remember when my father, who was a physician, was going to give me a measles vaccine, and my God, the needle was like this long, but then it turned out it wasn't for me, it was for my mother. Oh my gosh. Mike Wilson is in Olympia, Washington, where it's 48F. Dave says, listening to Twiv and Dr. Griffin keeps me sane in times like these. Well, we're here to give you science, to make a space that's safe for science, and we will continue to do it as long as we can. Sometimes I worry that we get shut down, right? This administration will do anything, but I'm hoping that we're so small that we don't, but we'll see. We'll keep it up. Yes, they restored EIS. Yes. But this is the thing. They don't think about stuff. They're just going to cut without thinking about what it does. The nuclear overseers is another example. This is just stupidity. You got a goal, that's fine, but you ought to really think about what you're doing before you just cut. Gwen, right? Gwen, I remember. Thank you. Welcome. Charles is in Lyndhurst, Northeast Ohio, minus 12C. Tao says hello to me and the people of Earth, 20 degrees, wherever you are. Taos, yeah, there we go. Please tell Amy we were thinking about her. I shall. Peter is in Calgary, where it's minus 27. Wow, that's cold. That is cold. Shrine says cryoglutenins or cold agglutinins are cross-reacting globulins, I guess antibodies, right? That induce reversible erythrocyte aggregation if blood temperature decreases and can also induce hemolysis. I see. So do blood temperatures decrease substantially enough to do that? I didn't know. And got an MMR shot a couple of weeks ago. Good. Very good. Gmo wants to know, who's from Pittsburgh, are you involved with using AI to invent and manufacture new proteins? How long will it take for AI to make cures for viral infections? I am not involved in any kind of laboratory research. How long will it take for AI to make a vaccine? I don't know. It's hard to say. It's hard to say what it would do. I don't know of anyone doing it, but then I don't know everything. 5 to 10 years it could be, designing immunogens, for example. You could use AI and you teach it, okay, these are nice immunogens, B-cell immunogens. Design me some more. And you have some criteria. Yeah, I can see that happening. Or T cells, right? Tryon says that patients with cold agglutination syndrome pulse oximetry indicate different values related to hand temperature. Okay. Vic says, I miss Rich, Kathy, Brian lately, but loving the Alan, Vincent, Angela. Yeah, tomorrow, no, Friday, we will have most people back. Yeah. We're going to do a tribute to Dixon on Friday. I'm going to reminisce about him. So you will have us back. Emmy says, I had a lovely great aunt who was blind from having measles. Do they still recommend measles patients stay in a dark room? I don't know. Yeah, I mean, light sensitivity is that a symptom? I don't know what docs recommend. Because I'm not a medical doctor, so I don't know these things. Okay, I don't get this, Mike. I remember the fear of polio as a kid. Oh, and the relief of my mother after the first round of shots in '54. I'm old. Yeah, it's about as old as I am. I was born in '53, and I got IPV in '55, I believe. Here's Tom continuing with Mark Twain. It was a good case of measles. It brought me within a shade of death's door. It brought the two where I no longer took an interest in anything. It brought me to where I no longer took an interest in anything. Mark from Zurich, 0 degrees C. And Will points out that I don't know everything, which I will heartily agree with. I know very little. Yeah, POTUS seems to know everything. That's fine. That's his problem. Okay, here is a quote in the COVID-19 textbook. Chapter 3, Linfa Wang writes, the failure of first-generation vaccines highlight the need to develop vaccines that are broad enough to prevent infection. Well, what are we talking about here? Oh, COVID. They didn't fail. There was antigenic variation. And we will not develop vaccines that prevent infection. It can't happen. Let me explain. We did a mini lecture on this, but I have to do it again. Let's say you have a vaccine that prevents infection, okay? You've developed one, which when you vaccinate animals, a few weeks after vaccination, if you challenge them, there's no infection. Okay, but now you wait 3 months when the antibody levels are high. Or low, sorry, they've gone down. And now you depend on memory B cells to respond. So the virus comes into you. It takes a few days for the memory B cells to be activated. And that time the virus is going to replicate. Hence, no infection preventing vaccines, except maybe in the first weeks after vaccination when you have high antibody levels. And even that is dicey, right? And a few months out, you're depending on memory cells. It will always take time. I like Livva very much, but I wish people would think about this and not say we have to make infection stopping vaccines. The polio vaccine does not stop infection. It's great at stopping poliomyelitis. That's what you need. Stop serious disease. Martha's in Charleston, South Carolina. It's not 0F. Vic says, wondering if, like polio, a person vaccinated for measles can become infected and shed virus. Yes, they can. The measles vaccine does not prevent infection. You can be infected. Okay. There is a mini lecture today. It was the one from last week, which I promised I would give you today. And it's funny. So this is a lecture on transcription and RNA processing. And it was supposed to be last Wednesday, right? And on that Wednesday, it was also transcription and RNA processing in my virology course. And while I was lecturing, I had taken slides out for the stream virology lecture. And I was up there thinking, what's the next slide? Because I was confusing the lecture with the stream. It's a very funny situation, right? But now we are moving we did DNA synthesis today, DNA replication. And Monday is reverse transcription and integration, where I reveal to you why some chicken eggs are blue. I mean, how can you wait for that? That's amazing, right? There were some questions I passed here. Let me see if I can find it. Long COVID, Mark Twain. So riffing more on Kang's comment, even if you want the states to do the research, this is very disruptive, this stopping of funding and indirect costs. It's going to last a while, and people can't pay people to stay, and they can't have them stay in their labs without paying them, so the lab structure is going to be destroyed. And I think it'll take it a while to set up whatever state thing you're talking about, if any, and it'll just really have a big impact on science. I mean, I tell you, I talk to a lot of people in academics. Everybody's freaking out. And it's not just because their people have to be let go, but they have no money to do research. Big problem, folks. Write to your congresspeople and tell them, why are you messing up science? I saw the press secretary, the lady, said, "Why did you fire all these people from the FDA food safety?" She says, "Oh, we want to have an efficient government with the most talented people." Not everybody gets that, and that's okay. So obsequious. Oh my God. They pull these obsequious people out of the woodworks. Oh my God. Well, I don't see the comments that I skipped, but that's okay. Virus that infects fungi, mRNA half-life. Anybody know if you should stay in the room if you have in the dark if you have measles? H2 says, I had measles when I was a child. I was told I will have immunity for life. Is that true? With more people not getting vaccine and me getting old, should I get an MMR vaccine when I still can? Well, I had measles also as a child in the 60s. It was before measles vaccine. And I haven't checked titers because I don't know what titer is good. Okay. So I'm not planning on getting an MMR vaccine. I don't think it's necessary. But you could talk to your doctor. Send Daniel Griffin a letter. Daniel at microbe.tv. See what he says. Trayan says, can SARS-CoV-2 produce defective interfering variants? Sure. Yeah, they do. I have a colleague who has worked on them, right? Let's look it up. Evolution of naturally arising SARS-CoV-2 defective interfering particles. A 2022 article out of McGill in Montreal. Yep, so there you go. Yes, you can get them. Yeah, there you go. Linfa Wang. I really like his work, but he shouldn't say infection preventing vaccines. Sorry, Linfa. Hey, you can't run the government like a startup company. It's so true. That's what they're doing, right? Filippo says, thank you for all you do. You guys keep me posted on what's going on in my practice and a clinical laboratory scientist. You're welcome. We do our best to try and get you the information that you need. Gwen says, might have a dead bird in my wreath out front on the side wall of the porch. Okay. If it's dead, you could leave it there if you don't mind, or you could just pick it up with some grasping device and then throw it away. If you got rural woodsy areas, just throw it away. Or if you're worried about dogs eating it, wrap it up, put it in the trash. Today I learned the word obsequious. Isn't it a good word? So many people in the current administration are obsequious. Smarmy, too. Do you know smarmy? Is a good one. Cutting the science budget is like killing the goose that lays golden eggs for Christmas dinner. What's weird is that historically the Republicans have actually supported NIH more so than Democrats. And now they're just sitting there mum, not saying anything. They could say, hey, we appropriated this money. It's not for you to cut it off and have a court fight. But they would not do that to their supreme leader, right? Sabrina says our congressional leaders are not leading. Most have capitulated to billionaires and the felon regime, a breakdown of government services that affects all Americans and especially the vulnerable. University of Kentucky lost $40 million in research funding, which has about a $600 million impact on the local economy, according to my econ prof. Yeah, every state is losing many millions of dollars, and not just in indirects, but in grant support going to laboratories. Carol said I had measles as a child. Titers were checked when I was med school, and I had titers, so I didn't need the booster. So you had titers, which means any titer is okay? Is there a certain level? Do you know the number? This is a good point, Susan Kay says. Scientists to begin emphasizing that blocking their work will block advancements in human disease treatment and public health. If they only complain about losing their job, then POTUS smiles. That's right. I said this on Tweevo today. Don't make it about you and your lab. Don't cry about your lab. It's not about that. It's about science in general. And Susan, that's absolutely right. I echo that. Yeah. So DHHS says to glove and mask up, bag the dead bird, and put it in the waste stream. Yeah, pretty much that's it. You could also call the city animal department. Sure, it's fine. So periodically, deer get hit by cars on my street. You call the animal department, and it's usually at night, and they say, okay, we'll be there in the morning. Then in the morning, it's all gutted. We're ready. It's all chewed out. Vultures and foxes and wolves and coyotes. It's recycled. I guess that's good. Kang wants to know: are there proteins like tau that have antiviral properties in addition to their primary function? What's the function of tau? Fundamental principles of existence. No, it's not the tau I want. Well, I spelled it wrong. That's why. I spelled it TAO instead of TAU. Yeah, it has a variety. Stabilizes microtubules, regulates microtubule dynamics, et cetera, et cetera. So yes, there are multiple functions. So are there other proteins that have antiviral properties in addition to their primary function? I'm sure there are. I can't remember any of them at this time. No, because since I don't think about them all that often, I'm thinking about intrinsic proteins that are always around. The apobec proteins have functions other than antiviral proteins, right? They're cytidine deaminases. So that's an example. Cuts and research are killing a lot of cities. Buffalo is going to start feeling the pressure, and I'm upset because I retired from the research foundation. Lisa says, I had measles as a kid. My doctor did a titer to validate when I was in college. He said I needed a vaccine because the titer did not show antibodies. So it was 0. So I just wonder if it's 2 or 5. Is that okay? Or do you need to have 10? What's the number? I don't know. Let's see. $120 units per mil. So I don't know exactly how that works, but that's a pretty high number. So 120, if you're below it, you don't have protection. It's the idea. Winfield says, did you happen to see that Montana's anti-mRNA vaccination bill failed today to pass the Montana House 34 to 66? Little good news. I think that's great. I think this is really good. Let's look it up. Montana anti-mRNA vaccine bill. Yep. Yeah, it would ban the administration of mRNA vaccines. That's a really stupid bill. Because, look, I'm glad they voted against it. What evidence do you have to say that you shouldn't be using it? A little bit of myocarditis that resolves in all cases? Really? And which is 10 times higher if you don't get vaccinated and you get COVID? Can you think, please? Ubalubi learned 2 words, so we have obsequious and, what was it, smarmy? Yeah. I had a colleague, when I was a postdoc, there was a graduate student in the same lab. She used obsequious all the time. That's where I learned it, because I didn't know it before. These aren't your grandpa's Republicans. Yeah, that's for sure. So even well, Eisenhower, no way. But even Nixon and up to the Bushes, they would talk to the Democrats, right? But then, nope, started to go down the tubes. No more talking to the other side. Here we go. Physician, gallbladder. Most patients with measles will experience photophobia. It hurts their eyes, so for symptomatic relief, they prefer a dark room. Or you could wear sunglasses, I guess, right? So you don't have to sit in the dark room. In the measles outbreak, is there any flesh-eating strains? No. No flesh-eating strains. Oh, here's a good one. Nevitz, smarmy, obsequious sycophants. Did you know that word? Where's Ubalubi? Sycophants? You know what a sycophant is, right? A sycophant is, so you flatter another person to get favor with them, which happens in the White House all the time, right? Smarmy is ingratiating and wheedling in a way that is insincere or excessive. And obsequious is obedient or attentive to an excessive or servile degree. Yeah. It may not apply to whoever it was I was talking, the press secretary. She's arrogant. Okay. I don't know what this Evo is. I'm sorry. I don't know what this is. Cosmic lettuce. I don't know anything about Evo 2. I don't know anything about Google's co-scientist. Anybody know? Please comment. Greg says the government is being run just like Twitter. When purchased, he fired 75%. Is tonight lecture about eggs and bird flu? No, it's not. It's not about eggs and bird flu. For the bird, you remember, you can just turn a plastic bag inside out and use it like a glove. So you grab the bird and you pull it over it and tie it. Yeah, no need to overthink. That's right. Did I mention Dixon's obit? Yeah, at the very beginning of the stream, Les put a link to it. Yep, for sure. Again, Patricia, a lot of people have asked this. I don't know. For a while they were doing 2 doses because 1 dose wasn't protective, and so you could use that as a reasoning to get a second dose. But as I said, I had it. I got it probably in the late 60s late 60s, and I think I'm not going to do a titer, and I'm going to be okay. Susan says the return on an investment of NIH dollars is year over year $3 for every dollar invested, no matter which economist does the analysis. Yeah, well, they don't care, right? They do not care. Jim Smith says 94% of kindergarten students in Texas are vaccinated. That's pretty good. I thought all the cases were unvaccinated. That's usually the case with measles outbreaks. Yes. Oh, so Tom says this Evo 2 is another AI release. I don't know anything about it. 97% of 7th grade students are vaccinated in Texas for MMR. That's a pretty good number, but the people having measles are not vaccinated, so that happens, right? I don't understand why it's so high and there's an outbreak. Something's wrong. My measles, Carol says my titer is positive. And Einstein, where I attended med school, did not feel I needed a booster. I used to teach virology at Einstein. Okay, if that's what they said, it's funny. They just probably didn't tell you the titer. Yeah. Jason says, I can't believe we are having to worry about measles in 2025. Yeah, it's ridiculous. It's a vaccine-preventable disease. It had been eliminated in the U.S. And then here we go with the anti-vaxxers, Wakefield, and all this crap. People who don't know what they're talking about. And other people who believe them, who listen to them. Why do Tamiflu and Xofluza only work in the first 48 hours? I think you have more time with Xofluza. But Tamiflu, yeah. Why? Because the replication cycle is so fast. It's already going down at 48 hours. So if you wait any longer, there's nowhere else to push it, right? So that's the reason. It's a really fast replication cycle. Luis says targeting the envelope of flaviviruses by inhibiting fusion could be a promising strategy. Yeah. Does the broad tropism of E make it undruggable? I don't think so. I don't think so. I think if you're hitting fusion, that's going to be different from the receptor binding, right? So it seems like it would be okay. Rita says an mRNA vaccine ban is in the state legislature in Idaho. It's so stupid. I wonder what the reason is. You think it will pass? Well, it's ridiculous. So what are they going to get for COVID vaccines? Novavax? I'd like to know why they think it should be banned. They obviously don't know anything. They got their science wrong. It doesn't need to be banned. Oh my God. It sucks. As Korn says, vaccines saved my life. There you go. Martha had her second flu shot. Medicare only pays for $115. Sorry, Martha. Hans says flu viruses mutate a lot and use reassortment to further increase diversity. Why can't flu A reassort with other types of flu? You mean with B and C? Well, I don't know how advantageous it would be because there are a lot of A out there already for them to reassort with, and that gives them plenty of diversity. But the sequence at the ends of the RNA segments control reassortment, and they're just different in B and C so that they're not compatible with A. That's it. Is more than one flu shot per season actually more effective than one? So in older people, if you get your flu vaccine, in August, um, it kind of wanes by flu season, like December. And so it's not a bad idea for them to get um, a second shot. Have trials been done to assess that? I don't know the answer. That would be the question. Have clinical trials or observational studies been done to show, actually, to demonstrate that uh, a second shot is beneficial? I don't know. Good question. Question for Daniel Griffin. Daniel at microbe.tv. WRD78 says, with the current administration in charge, do you feel it's feasible to improve science communication to the general public? I'm concerned about the resulting health risks. I definitely think it's feasible to improve it. I don't know what you mean by health risks. You mean risks on the communicators? No, I think we need more people speaking out, not just Microbe TV and a handful of other people, right? More. I've been saying this for years. Every scientist needs to do something, but they didn't listen. And so I think at this point you need to educate all these people in the U.S. who don't care that the NIH and NSF and CDC are being trashed. You have to educate them about what's going on. On Tweetville today, Nels had an interesting pick, a guy on Blue Sky who is trying to explain everything that's going on with the cuts and so forth. So that's good. But I think we can do it. Yeah, I think we can improve it. I think Microbe TV is doing as much as it can. I mean, I don't have the resources to do more, right? It's a pretty small operation. We crank out a lot of shows a week, and we can't do more. But other people need to help us. Obeisance. How do you pronounce it? I know the word is paid obeisance. They paid obeisance to the princess, a gesture expressing deferential respect, such as a bow or curtsy. Yeah, that applies here. He's Areozone. I don't know, is Gail, are you asking me this or are you asking yourself? Do more frequent shows if other reliable info is less available? I think we do a lot of shows as it is. There's always room for something more, but we need to get some help to do that. Hello, Doreen. Nice to see you again. It's been a while. Had a second flu shot too after Dr. Griffin said he did. My Medicare Part D did cover it. Good prescription coupon can be used too. Okay, thank you. Okay, Tom explains that Evo 2 is an AI to design genomes, apparently, compared to AlphaFold and proteins. Okay. Look up the etymology of sycophant. Let's see. Interesting. The sycophant word comes from the Greek, which is a combination of fig and to show. The original meaning of the word was informer, a person who reported criminal activities. The prime minister is surrounded by sycophants. I think the POTUS is surrounded by sycophants, right? Word night tonight on office hours. Filippo said, as a federal employee working in science, the last few weeks have been a nightmare. I would have taken the fork in the road, but then learned we weren't even eligible to resign. When you reach a fork in the road, you should take it, right? So Tim is talking about Gaines County in Texas with the 45 of the 58 measles cases, and it has one of the highest exemptions. So this is the problem. You have clusters of medical exemptions, and that's how you get outbreaks. Yeah. Steph says microbe TV. That's me. Science education is becoming more and more important. Can't thank you enough for your efforts. Yeah, it is important. Just teaching people science. I do a mini lecture now. It's important to do that. Who else is going to do that? Well, despite being my native language, I was never good at English. I didn't expect for that education here, but I'm grateful. We crowdsource many things here. If it's not virology, it's other things. I'm still eating eggs. No, why should you worry about eggs? No, the eggs are not the problem. The chickens are the problem. And so if the layers get infected, they have to cull them, and therefore you don't get your eggs. That's it. And that's not because the eggs are contaminated. Yeah. SciTeach 84. I'm a high school science teacher. I teach biology, anatomy, physiology. I'm curious about your thoughts on the current climate of high school science education. Well, I don't really have much contact with high school science teachers, but I used to go to classes to teach high school, to do a class here and there to teach some science. And it seemed to me that the teachers were making the kids memorize facts, right? Which is really boring. They don't want to memorize facts. What you should teach them is discovery, how things were discovered. But maybe it's hard for science teachers to do that. Maybe they don't have the background. I don't know. But, I used to look at my kids' curriculum, and, they're just memorizing stuff. And I think that turns them off. You got to turn them on and tell them okay, here's a cool fact. Here's how it was discovered. This guy got up one morning and did this, like Leeuwenhoek inventing a microscope and seeing tiny things swimming around that nobody had seen before. Stuff like that. I think that's what we need to do. But I don't know how you change the whole system. People tell me it's impossible. I think more. And now that many scientists are going to be out of a job, maybe they should go become science teacher, because I always said that a trained scientist would be a good teacher, or could be in theory. Not everybody is a good teacher, because they would know the discovery part and they could teach that. Yeah. Dean wants to know, what's the IFR, the infection fatality rate of measles? I don't know. Okay, so here we have a document, NIH. It depends. It varies from 0.1% to 30%. So here they have one chart: 3% for children under 1, 1.6 for children aged 1 to 4, 0.84 for aged 5 to 9, 0.67 for 10 to 14. So it decreases as you age. And of course, if you are malnourished, it goes up too, very high. How scared should we be that they have found chronic wasting disease prions in feral swine? So I'm not too scared, because these CWD prions don't look like they can infect human cells. And we talked about this a couple of weeks ago, actually, in a mini lecture, which is not to say that they won't change, right? But I think we should be careful, but I don't think it's a problem yet. Yet. It's an interesting question, though. Very interesting question. Cosmic Lettuce says, education as we know it is over. You think? What's it replaced by? All the good things, huh? Doreen says, no doubt we're going to have a big measles resurgence, also polio and pertussis. Yep, for sure. Yeah, so measles first and polio, pertussis. Maybe I has to pull off it. He said maybe a couple of years to get to really big numbers, but it'll happen. Yeah. And I don't know what the response is going to be, right? Because I don't know what the CDC is going to look like by then. And Kang says, rightly, there are Texas counties where the MMR vaccination rate is definitely not over the 97% statewide. So these are pockets of people who don't vaccinate for various reasons. David says, do you keep any of the new rapid flu tests at home? Yeah, this is a good one. There's COVID and flu A and B. I don't. I should, because that would get you antivirals quicker, right? Yeah. Okay, so there you go, right? Lise says there's one county in Texas that's having the outbreak. Gaines County with one particular school district, 45% vaccine exemption. Yeah, this is the problem with Texas. They have huge, high rates of vaccine exemptions when medical exemptions should not exceed 1% of the population. That's about the rate of any kind of illness that would call for an exemption. But 45 is ridiculous. Frank, you were a source of sanity during the pandemic. I'd like to know your opinion on the claims that mRNA vaccines are now harmful. It's ridiculous. It's baseless. There's no data to support it. The only things I can think of are, one, there is a low rate of myocarditis associated with mRNA vaccination. Not fatal, completely treatable, and in all cases resolves. And its myocarditis is much higher if you get COVID. So it's always, right, you always have to do the risk-benefit calculation. The other is this fear that the mRNA is going to integrate into your DNA, driven by some crappy experiments done in cells in culture by scientists who should know better. They're crap. They mean nothing. So mRNA, they put them in cells with lots of reverse transcriptase, so it gets converted to DNA, and then it can integrate. Yeah. Does it happen in people? We have no evidence that it does. Most of the cells would be somatic cells. If it integrated, they would turn over very quickly. But you say, okay, what happens if it goes into a germ cell and you pass it on to your offspring? We have no evidence that this happens. There were studies done to look at mutagenicity, and they showed nothing. So people get worked up because they have nothing else to do. There's no evidence that they're dangerous. There's no evidence that they should be banned. I'm flabbergasted that legislatures are considering this. This is not science. This country is drifting towards being non-science run, public health in particular. Sabrina, things are going backward. No one has had the backbone to have prevented in the first place. Now we're all suffering. Yeah, it's unfortunate. Dave B. writes, mRNA vaccines also hold promise for the fastest development of custom cancer vaccines in the future. Ask any of the naysayers if they'd reject that as an option. This argument makes them flip. So yeah, I did get to that. Vaccines are not now harmful. They were and are successful at reducing the likelihood of bad outcomes with COVID-19. Absolutely. I'm not sure we can refer to this presidency as an administration because they don't administer anything. They break things, right? Have I reached out to AOC Bernie Sanders? No. What should I do? Tell me. I can reach out to them, but what do you want me to do? I get texts all the time from Bernie. What should I do? Tell me. So Fishbone wants to know if school district vaccination rates are available to the public. I think you can go to the state health departments and get that information, I believe. Or Temis says, obeisance in French is the act of obeying. EHS says a substantially dumbed down show is needed. Lay people can't follow anything, even slightly complex. Yeah, I agree. I agree with that. We do make some shorts, which I think are easier to digest, and we should do more of that for sure. Gwen says, why are parents not vaccinating? Because they're listening to anti-vaxxers that say it's dangerous. I think that's one thing. I think another thing is that I think some people have trouble getting their kids to doctor's offices for multiple shots. I don't think that's a insidious reason. They can't do it. They have jobs and they just can't do it. So maybe we have to make vaccination easier. Do it at schools. Yeah, you could see that happening in this administration, right? I think the main reason is they listen to Andrew Wakefield and his ilk, and they believe him, and they don't hear us. Or Wakefield will say, Racaniello is under the control of Big Pharma. He gets a lot of money from them. By the way, folks, I don't get money from Big Pharma. Okay? I don't. All right. So H2 says, Vincent, what practical help can you use to expand the impact of TWIV and microbe TV, aside from donating money? Oh, we need to make short, digestible content, and we need help from people to do that. You can write a script, you can record it yourself, and we can produce it and post it for you. But if I could get different scientists explaining things in a simple, short way, that would be wonderful. Not just us, right? That would be one way that would really be helpful. Let's do some. Let's do a mini lecture. Okay, it's 9:13. There's some good questions left, but let's do a mini lecture, and then we'll get back to this. All right, transcription and RNA processing. What is this? What is this all about? So here's the Baltimore scheme where, I don't know if you remember, there are 7 different kinds of viral genomes, right? Double-stranded DNA, single-stranded DNA, DNA with a gap, double-stranded RNA, minus RNA, plus RNA, and then plus RNA with a DNA intermediate, the retroviruses. All of these 7 genomes have to make mRNA to make proteins, right? That's how you make proteins. You make mRNA, and then the ribosome makes a protein from it. And so for DNA viruses, which we're talking about today, they have to make mRNA from their genomes, and that's called transcription. And transcription can only happen from double-stranded DNA. So the enzymes of transcription copy double-stranded DNA, and they make mRNA. That's called transcription. There are other meanings of transcription, right? Copying words in a certain way. But in biology, this is transcription, taking double-stranded DNA and making mRNA from it. And so these DNA viruses all do that. Now, the key here to understanding the infectious cycle is that for DNA viruses, they need to make at least one protein and sometimes many to get DNA replication. So a DNA virus needs to make more of itself, right? It needs to make more DNA and put it in capsids. But before DNA can be replicated, you need at least one protein. Therefore, the first thing that happens when these viruses infect cells is that transcription occurs to make mRNA so that this one or more protein can be made. So this is an example of SV40, which has a double-stranded DNA genome in a circle. And when these viruses infect cells, the double-stranded DNA gets in the nucleus, and it's actually ready for transcription. It's double-stranded because remember, I told you that only double-stranded DNA is a template for transcription. But not all templates are ready for transcription. I'll show you. So the hepatitis B virus genome, which is weird, it's partially double-stranded, partially single-stranded. It's got a piece of RNA stuck on it, and it's got a protein stuck on it. So it's really, really weird. So that cannot be transcribed. So when it gets in the cell, it gets in the nucleus, the cell looks at it and believes that it's broken and wants to fix it. So it does what's called DNA repair, and it makes it into a beautiful closed circular double-stranded DNA inadvertently, because now this can be transcribed and start the infectious cycle. So the cell does the virus a big favor. Same thing with single-stranded DNA viruses. Gets in the cell says, we don't really like single-stranded DNA around here. It repairs it. And it makes it double-stranded, so now it can be transcribed and make a protein that's needed for DNA replication, right? So then we have the retroviruses where the genome is RNA. It's not ready for transcription. It has to be converted to DNA. Then it has to integrate into the host DNA, and then it can be transcribed. So you see, with the exception of SV40 and similar viruses, papillomaviruses, DNAs are not ready for transcription unless a few modifications are done. Now, hold on a sec. So remember, you have to make a protein, therefore the DNA has to be in a state that can be transcribed. All right, so this transcription can be done by enzymes of the cell, and that's largely what happens. So there are three DNA-dependent RNA polymerases in the cell that make RNAs of various sorts, Pol 1, 2, and 3. Pol 1 makes the precursor to ribosomal RNA. Pol 2 makes precursors to mRNA and microRNAs and others. And Pol 3 makes precursors to tRNAs, transfer RNAs, right? And these are utilized, the Pol 2 and 3 are utilized by various viruses to make their RNAs. Interestingly, viruses that replicate in the cytoplasm, like pox viruses and giant viruses, they encode their own DNA-dependent RNA polymerase. Why? Because that enzyme is in the nucleus. That cell enzyme is in the nucleus. And so if you replicate in the cytoplasm, you can't get it. So you have to make it. So it's encoded in the genome of these big viruses. Very interesting. All right, so let's talk about making mRNA. We have a nucleus here. Here's the nuclear membrane. Cytoplasm in kind of tan and nucleus in gray. The DNA is in the nucleus. And the polymerase binds the DNA at a specific site and makes what's called a pre-mRNA. It's a pre-mRNA because a couple of things have to happen. First of all, poly A has to be added to the 3' end. And there are extra sequences in these mRNAs that have to be removed. They're called introns. And they are removed by a process called splicing. And that leaves exons. So 2 words, maybe you didn't know, intron and exon. Not as interesting as obsequious, I think, but they serve their purpose. And now we have an mRNA with a 5' cap, and the introns are removed and a poly A tail. That can be exported into the cytoplasm and translated into protein. So, and this is where the half-life of this mRNA comes into play. It's a question that I answered earlier. The mRNAs are eventually degraded. You can't keep them around forever. And that half-life is controlled by sequences in the 3' non-coding region. Okay, so this transcription that initiates here at this red arrow, so the RNA polymerase binds and makes mRNA starting there. It's regulated, highly regulated by a bunch of sequences. So this is what we call the promoter of a DNA, which specifies transcription. And here's the red arrow, which shows where mRNA synthesis begins. And then we have all different color sequences here. This yellow one specifies where the mRNA should start. And then there are binding sites for all kinds of different proteins that regulate transcription. Transcription is highly regulated. You can make a lot of mRNA or you can make a little, and that's controlled by all of these regulatory sequences that bind proteins. So this is called a promoter. Now, the way this works is really interesting, and that is we have a piece of DNA with a promoter. It's yellow here, and here's our transcription start site in red. And a lot of proteins plus the RNA polymerase assemble at the promoter. A lot of proteins are needed for this, initiation proteins. You can say they make this big complex, which doesn't do anything until ATP is hydrolyzed. That's an energy source, and the complex becomes open. And this complex opens up, and then it can begin transcribing and making RNA. And I wanted to show you what this looks like at a molecular level here. Here's the RNA polymerase. And here's the active site where new bases are added to the growing RNA. Here's the RNA. So the DNA comes in, and the strands are separated, and one strand goes into the active site where it's copied to make mRNA, which comes out the RNA exit channel and the polymerase, as you might imagine. And then the DNA renatures and goes out another channel itself. And finally, the NTPs that are added to the mRNA come in a channel on the back of the enzyme. And so that's how it works. That's how enzyme RNA polymerase II makes mRNA from a DNA template. Now, different viruses do this in slightly different ways. So some viruses here, retroviruses and others, they use entirely host proteins to make mRNA. They don't use any of their own proteins. Some viruses have one viral protein that regulates transcription in some way, and the rest is the host. Some viruses have more than one viral protein that's involved in transcription. We'll see some examples of that. And then we have viruses like viruses and Mpox viruses, big viruses that reproduce in the cytoplasm. They have their own transcription system, right? They have everything, RNA polymerase, all the accessory proteins. Why? Again, and I touched on this earlier, it's because they're replicating in the cytoplasm. They're making new viruses in the cytoplasm. So they have to make mRNA in the cytoplasm. And the enzymes to do that are in the nucleus, so they're not accessible, so they have to make their own. But they can because they have big genomes. It's not a problem. Now, I want to talk a little bit about regulation. So we see two features of regulation of transcription. what we call cascade regulation and positive or negative autoregulatory loops. Cascade regulation is shown here. We have gene X, which is driven by a promoter. So gene X is transcribed to make an mRNA, and it makes a protein. Then that protein activates a second promoter for gene Y, which then makes mRNAs. So the second promoter will not work unless the first one is made. The first protein is made. So that's cascade regulation. And then we have positive loops where we have a gene here, X, transcribed, protein is made, and the protein stimulates transcription. So it's a positive stimulating of its own transcription. And you can get negative regulation as well. So let's look at some examples of viral transcriptional programs. This is a lot of fun for me. I hope you like it. So here's SV40, a double-stranded circular DNA. It has two promoters. It has an early promoter and a late. What does that mean? Well, early, when the virus first infects cells, that's early for maybe a couple of hours, and then it becomes late. But there's actually a definition of late, which you'll see in a moment. So when the DNA gets into the cell, it goes in the nucleus, and it's transcribed to make early mRNAs. And that late promoter is not active early in infection. And the early mRNAs encode a protein called large T antigen. Large T antigen is needed for DNA synthesis. So it activates viral DNA synthesis. And that eventually turns on the late promoter. So it's a cool example of cascade regulation, right? Large T is made first. It then activates DNA synthesis, which turns on the late promoter. I think it's very cool. Now, why is the late promoter off early in infection? Well, that is because there is a cell protein called initiator binding protein that binds to all the elements that regulate the late promoter. So here's the arrow for the late promoter. And this initiator binding protein is binding up all these elements that are needed for transcription. So it's silent early in infection. But then in the late phase, when DNA synthesis occurs, now you have lots of DNAs being made, and there isn't enough IBP to cover all of these regulatory sites. So then the late promoter becomes active. So it's very cool that a cell protein regulates this. And the cell protein levels are always the same, which is why this works. And so early in infection, here's a time course, time after infection and relative concentration. So the initiator binding protein level is always the same. Viral genomes do not start to replicate until the late phase. And then when genomes begin to replicate, the late RNA is made because of the titration out of initiator binding protein. So why do we have early and late phases? There's one reason, and that is to delay the synthesis of structural proteins until we have DNA to put in the capsids, right? If we don't have DNA, what's the point of making capsids, making the late proteins? So we have an early phase where we start DNA replication, and once that reaches a certain level, then the late promoter becomes active, and you make capsid proteins that can then encapsulate the new genome. So here we have SV40 DNA coming in the nucleus. Early promoters active, T antigen is made. T antigen goes in the nucleus, stimulates DNA synthesis. And DNA synthesis then turns on the late promoter, which encodes the capsid proteins. And these go in the nucleus and encapsulate SV40 DNA. So it's a beautifully orchestrated set of reactions. Adenovirus is a little more complicated, but still understandable. We have more proteins involved. So we have not just early and late, but we have immediate early, and late. transcription. When the genome gets in the cell, first things that happen is the immediate early genes are transcribed, which include a protein called E1A. E1A is necessary for the transcription of the early genes, the E genes. And those encode proteins involved in DNA replication. So they turn on DNA replication, and then in turn, as DNA replicates, the late promoter becomes active in a similar mechanism to what I just told you. Okay, so that's what's going on there. Now, what is this E1A doing? This is really interesting, and when we talk about cancer, this will be relevant. Now, the virus, in order to have the early promoter active, it needs a transcription protein called E2F. And E2F is in the cell. It's a cell protein. It's usually inactive because it's bound to a cell protein called RB, retinoblastoma. And so this is sitting on promoters, but it's inactive because it's got RB bound to it. And what E1A does is it binds RB and frees up E2F. So now E2F can act on promoters to allow them to be transcribed. Now, how RB works is really interesting. It's a little bit deep here, but let me go into this. So when RB is at the promoter site, it recruits enzymes called histone deacetylases. And they remove acetyl groups from histones. So DNA is normally wrapped around proteins called histones, and this has this configuration called chromatin. And when you have an acetyl group on the chromatin, the DNA is relaxed and it can be transcribed. And so that's the state here at the bottom where we have E2F able to turn on the transcription of relaxed DNA. But when RB is there, it recruits histone deacetylases, which take off these acetyl groups. Now the chromatin becomes closed and it can't be transcribed, right? Yeah, and so here we have RB recruiting histone deacetylases that tighten up the chromatin and prevent transcription from occurring. And so E1A of adenovirus gets rid of RB and allows transcription to occur. Very cool. Now, adenovirus has a complicated transcriptional program. It has a double-stranded DNA genome. It has transcripts, pre-mRNAs made from both strands of the DNA. Here we have the early region mRNAs. You can see the DNA polymerase and DNA binding protein. These are enzymes involved in DNA replication. And then we have the late mRNAs that encode the structural proteins. And then we have the immediate early proteins here, E1A, E1B, among others. And so a very complicated schematic here. So here's how adenovirus works. The virus comes in the cell, docks on the nucleus, the DNA is in the nucleus. The immediate early genes are transcribed. You make immediate early mRNAs, including E1A. E1A goes in the nucleus, and it frees up E2F so you can get early transcription, which encode the DNA polymerase. So those proteins go in the nucleus and stimulate DNA replication, and that stimulates late transcription, which encodes the capsid proteins, and that's how you get new particles made. Okay. This scheme that I showed you before, the synthesis of precursor RNAs that have introns that have to be removed, this was actually discovered in adenovirus-infected cells. So here's the adenovirus genome, and years ago, investigators, Phil Sharp and Rich Roberts, were doing experiments where they would take an mRNA, in this case encoding the hexon, which is a structural protein, and they would hybridize it to the viral DNA. And they always found sequences in the DNA that were not present in the mRNA. So they thought, something is being removed when we make the precursor mRNA and then make the final mRNA. And so this was splicing that they had discovered, for which they got the Nobel Prize in 1993. Amazing process, which has since been found in all viral genomes and all cellular genomes as well. Incredible, discovered in the 90s in adenovirus. So what's this about splicing? Why is it good? Well, for example, you can have an mRNA with 2 introns. You remove them both. Now you have this mRNA encoding a protein with 3 exons. This is called constitutive splicing. Then we have alternative splicing, where sometimes you remove one and sometimes you remove the other. So we have 1, 2, 3 or 1, 3. And so on and so forth. You can have alternative 5' and 3' splice sites. So basically, splicing can give you many, many more mRNAs and therefore many proteins, more proteins than you would ever have without splicing. And here's an example from adenovirus. The major late mRNA is a very long precursor that has lots of introns, and it has 5 polyadenylation sites. And so these polyadenylation sites are utilized, and you end up making 5 mRNAs with different poly-A sites. These are then spliced in different ways. The introns are pink, and you get lots of different mRNAs encoding different proteins from splicing of this single precursor. So it gives you a flexibility in your genome. Now, the last thing I want to tell you is that when splicing happens, it allows mRNAs to get out of the nucleus. So here's a pre-mRNA that's going to be spliced, and lots of proteins bind to it in the nucleus. These are splicing proteins. And some of them remain, and they are recognized by the export pathway. They let the spliced mRNA out. So in other words, if you're not spliced, you can't leave the nucleus. So the problem is that some viral genomes need to get out of the nucleus without being spliced. So a great example are retroviruses, where the whole genome needs to get out, but it normally would be spliced. So how does it get out? Well, there is a sequence element at the 3' end of the RNA called a constitutive transport element, which binds these factors that allow export. So it gets around this by having a sequence element in its own genome. So splicing is value added. You can make different mRNAs, different proteins. You can expand the coding region of a small DNA genome, and you can regulate gene expression. Okay, that's a very, very brief overview of transcription. As always, things were discovered in virus-infected cells. Back to the questions. Okay, Brandon wants to know, how did I cultivate curiosity and independence? So I no longer have any trainees, right? So it's all what I did. I let people be independent. I wanted them to pick their projects, and if they couldn't, of course, I would help them. Most needed help. And then I wanted them to set up the first set of experiments and go do them, and then bring back the results and tell me what they were going to do next. So I didn't tell them what to do. I think that's the key, unless they ask for help. So if there's a methods question that they have, you can help them and so forth. But let them go through the whole project and say, okay, here's my result. It means this. What are you going to do next? Well, I think I should do this. And you let them run with it. I think that gives them independence. Now, everybody's different, right? So some people need different amounts of independence compared with others. And you have to be able to sense that some people are different from others. You have to give them more help than others, right? So recognize that everybody is different. But let them do as much as they can. Don't overwhelm them. Don't give them to a senior person who is just going to use them as a pair of hands. It's no good. I hated that. Let them go on their own. And they will find people who are useful in the lab and ask them for help, for sure. Uh, there's there's nothing that the IFR and the R naught are two different things, right? Infection fatality rate versus supposed transmissibility. Okay, that's the R naught. That means that an infected person on average can infect 18 other people. Okay, a number I have a lot of trouble with. You provide excellent science communication. I'm concerned for those who don't listen. I don't feel this administration will make SciComm a priority. All right. So we've always been concerned about people who don't listen. We are not entertaining enough to have people listen all the time. I agree. I understand. I get it. We have complicated stuff. But look, we're building. We're building slowly. And we're attracting more people these days. The numbers on YouTube go up faster and faster. So, uh, I just want to try new things and not necessarily expand very quickly, but just try new things and see how they work. Like we started doing a lot of shorts and people said they really like those. Okay. So I think we can do this in the face of this administration because they don't care about what we're doing, essentially. Pete says Sabine Hassenfelder is doing SciComms. Yeah, she makes mistakes, Pete. She doesn't know virology, so she makes mistakes all the time, right? She needs to check her stuff more. I don't know how she prepares, but she just makes very common mistakes in virology. I'm sorry. Yeah. I mean, I think you have to stay in your field. I do virology, right? I casually touch on other fields just inquisitively. Oh, what does this mean? I don't know. I am by far not an expert in anything except viruses, okay? So I stick with that. And I think people need to do that. That's your strength. You know what you're talking about. Otherwise, you're going to get in trouble. See, this is an example. Artemis, for my biology exam, I had to memorize the pKa of this is ridiculous. All of my exams in my course are open book, open note, open everything. And still people don't do well. I want them to learn the concepts, not the facts. The facts are in your notes. I want you to understand, and that's hard to do that, like the stuff I gave you today. Yes, here. Filippo says, you mentioned teaching science through discovery. I do the same in the lab when explaining DNA. I start with Friedrich Miescher. For mass spec, I begin with Gauss. What's your fave? I don't really have a fave. I think there are a lot of great people who have done amazing things in science, but I agree that you should teach them a little history. Not too much, though, because they're going to get turned off. Just enough to pique their interest. Post article today about how admin considering destroying stocks of COVID tests. If you haven't ordered your 4, you still can. This is so disgusting. So disgusting. Filippo says he's excited for the new noro vaccines. I hope they work well. Yeah. Ariozone says there are several actions planned for the coming weeks. Friday, do not buy anything from large corporations. Have you heard about this? No, I haven't. I haven't heard about it. GSD, yes. This was an earlier question that I missed. The feasibility of using a LAV vaccine as a challenge to study a protein subunit designed against the same unattenuated virus, just like the Japanese encephalitis, yellow fever vaccine. Where is it? I want to find your original question. And then I'm going to get lost. But that's fine. We can do that. I have to just remember your icon. I can't find it. Can you just repeat it? And hopefully we'll get to it, right? I don't remember the original question, so just repeat it. Just repost it. Tell Bernie your concerns. What your concerns are regarding defunding science, etc. Okay, what about AOC? What do you want me to tell her? Greg says a dear friend has become anti-vax and said she would take her chances with rabies. Okay, I'm less interested in that and as to why she became anti-vax. Did you ask her that? I mean, calmly, just to find out what's going on. I think that would be interesting. See, so Will says shorts are incredibly helpful because they're short and their subject is clear and limited. Yeah. So we do a lot of those. Yeah. Artemis keeps meeting people who believe if you don't have fever, you can't be contagious. Well, that's just not true. Of course, you can be shedding without fever. So Pete says UK has some good SciComm. Brian Cox, Jim Alkalili, Hannah Fry, Alice Roberts. Oh, there's many good people out there doing SciComm. Yeah. Is teaching the Baltimore classification really good pedagogy? Oh, yeah. Oh, yeah. That chart, if you've not looked at it, go look at it. It's got so much information packed in. The logic is impeccable. And for them to just understand how it works is beautiful. And I don't make them memorize it because everything in my course is open book. But the key is I can tell you, here's this genome. How does it get to mRNA? And, you need to know a few things like only double-stranded DNA can be transcribed and a few other things. But you can do it. It's great. Yes, I've taught it for ages, which is not a good reason to keep doing something, but I find it really works. They get it. HPV TWIV was great, but left unanswered questions. January is cervical cancer month. Next January, can you invite a guest gynecologist and discuss HPV? Yeah, we can do that. But we had a guy on from Stockholm last year who talked about HPV. He was a doc. But we can do another. Dan, thank you for your support of science communication. Really appreciate it. So, first vaccine, adenovirus, fine. I presume this is a COVID vaccine. Booster last November, mRNA, severe muscle ache and nosedive of very rare stage 4 thymic carcinoma. Oncologist has given maybe weeks. Could mRNA be worse than adenovirus? So Dan, I'm sorry that this happened, but then it may be unrelated to the vaccines, right? Even though I know that the timing is there, but it may have happened. Maybe it was going to happen anyway, right? So no, I don't think either of. So adenovirus had other problems with clotting, which were more severe, right? So they were removed, but I don't know that you can make any conclusions from this. You need to do so. First of all, none of this is observed in the follow-up, the millions of people who were followed up after immunization. So if this were an issue, that would have been seen there. Yeah. Yes, personal anecdotes are not how you determine vaccine safety. That's absolutely right. What types of qualities allow viruses to establish latency? Immune evasion and modulation of killing of the cell. You can't kill a cell to become latent, and you have to avoid being eliminated by the immune system. Those are the two main things. Dr. Bro Shropshire, thank you for your support of science communication. We really appreciate it. Transcription rates up to 40 bases per second. That's right. How can diffusion be that fast? Well, remember, they were talking about very small things here. So diffusion can be fast. And you know what's interesting? That you don't know which nucleotide to pull in the channel, right? If there's a T there waiting for an A, the polymerase can't pick an A. So what happens is all four go in, and the right one hits it. So, and that's amazing because 40 bases per second, and for each base, it's trying out four different NTPs. So how cool is that? Right? At least has some podcast news. Joe Rogan, no longer #1. Midas Touch has toppled Rogan. So Midas Touch is that democracy podcast, right? I think I've seen a few of those. That's good. You know, but the thing is, they're always, they're always saying, "Oh, Trump did this and that," and nothing becomes of it because he's like Teflon Man. But anyway, I'm glad that Rogan was deposed because this is garbage. He has real medical misinformation and nothing is done about it. I don't get it. All right, how do these infectious viral particles escape the host's immune system? Well, they don't all. I mean, you're assaulted with many, many virus particles a day, and most of them are eliminated. Okay? They're trapped in mucus, or if they do start to replicate, they're taken over by interferon responses. Very few make a foothold. Okay? So the vast majority of viruses that assault you are taken care of and cleared very rapidly, and you don't know it, but that's your intrinsic and innate immune systems. Yes, here we go, John. That's it. The thing I feel most useful about the Baltimore classification is the concept that all pathways get to mRNA. That's right. You put it in the center. And the pathway is the good teaching point, because then you see, okay, double-stranded DNA to mRNA, that's easy. But what about single-stranded? Single-stranded, it can't be transcribed. It has to be repaired. So all of that stuff comes into play. I love that. Here we have a great explanation from Nevitz. Acetyl groups remove the positive charge on certain lysines of the histones. That in turn breaks the electrostatic interactions with negatively charged DNA. Hence, DNA relaxes and it's open and it can be better transcribed. Very cool stuff. Very cool stuff. Yes, Steen. I always used to ask Dixon, how many types of virus genomes are there? And he would always say 7. Yeah, that's right. It's right. Good memory. I had forgotten that. I have to remember that Friday for my for our reminiscing. Yeah. And every step in these pathways that I just talked about, right? Every DNA binding protein took years to characterize and work out the details. Hundreds of researchers, NIH supported, and the future of this is in question because someone wants to break it. It's amazing. Yeah, of all the PhD students I had, who accomplished the most in virology? I meant most of them left virology. I'd have to say it's Amy. right? She she remained a virologist, tried and true, and she's continuing to do virology, unlike most of the other students that I had. Yeah. SciShow, yes, popular YouTube channel. They make short videos. They're entertaining, right? They have funny people. It's not for me. I don't mind being loose and funny, but they're just acting way too much for my. But it's maybe that's what people want. That's fine because they're really successful. They make a lot of money. But let's see how much they actually teach people, right? Kang wants to know, why do some DNA viruses make and use their enzymes instead of the hosts? So, so the viruses that reproduce in the cytoplasm, they make their own DNA polymerase and RNA polymerase, right? So that's a necessity of being in the cytoplasm. But the adenoviruses and herpes go in the nucleus, and they still make their own DNA polymerase, not RNA polymerase. DNA polymerase. Why? Because you can have more control over it, right? You can you make the DNA polymerase and all the accessory proteins, and you have control over what it does, so you can easily tweak the replication cycle as fit for your virus, because it's not a host protein that you've co-opted, and you're limited by that. What's the impact of rats testing positive? Another animal that can be infected and spread virus, and it's not going to stop at rats. But rats are close in urban populations, close to many people, and so the concern is transmission to people. I don't know if it will happen, but that's the concern. Yeah. SciShow is not interested in microbe TV. We're the opposite of them, right? Because we're serious and we have hard science, and that's not what they want. And we're not going to help them at all. All they would do is help us. Yeah. Wish you had been my cell biology teacher. I had not a hope in hell of memorizing TCA cycle. Yeah, I don't believe in memorization. I want you to have your piece of paper with info on it, and then I ask you questions that test your understanding of what's going on. The concepts, not memorization. I don't want you to memorize stuff. I want you to understand the concepts. Yeah. Yeah. Yeah, so that's another way of putting it. Rich Condit says these DNA viruses that reproduce in the cytoplasm avoid the nuclear bureaucracy. They stay out of the nucleus. They make everything they need in the cytoplasm, because everything for transcription and everything for DNA replication. All right. I think we're getting towards the end here. We've had over 200 people. That's great. We have over 200 likes. Wonderful. Thank you so much. Tona, why is the HPV active for 16 months? So that's the cycle of the virus and how long it takes to be eliminated by the mucosal immune system. Those are all women who did not develop cervical cancer. So, but that may be related to cervical cancer, because what happens in cervical cancers is that a piece of the viral DNA breaks off and integrates into our genome, and then a protein, an oncoprotein, is made forever, and that's what causes the cancer. So the long acute phase may be part of the reason why you get these cancers. Yeah. Okay, Jonathan was wondering if a Flavy combo protein symbiote could be tested with a Zika virus LAV vaccine challenge. I don't know if they could do that with Zika virus, right? It's a bit of a problem. So I'm not sure you could get away with that. All right. Yeah, you do have lots of hours of Dixon to watch. You can go back and see them again. All right, folks. lots of good comments here, but I think it's time to wrap this up. I want to thank our moderators tonight for being great moderators. I know there was a lot of activity going on there, some nonsense, and they took care of it. Thank you so much. Appreciate it. Les, thank you so much. Tom, thank you so much. Vanity Nutrition, thank you so much. And Steph SF, thank you so much. Really appreciate. Did I get everybody? Vanity, Steph, Les, Tom, thank you so much for moderating. And everyone else, thank you for coming. You come week after week. I'm always waiting for no one to show up. And I'm always surprised. So that's good. 200 or so people a night wanting to learn science. And I will do this as long as we can, right? Because science is cool. All right, we're going to be back next week, right? Let me check the calendar. What do we have here? Come on, calendar. Today is the 19th. So let's copy office hours and put it on the 26th of February. That's 8 p.m. Eastern. Bring your questions. If you had some today that weren't answered, please bring them. I love to answer them, and I'm sorry I don't get to all of them. So thanks everybody for coming. Until next week, I want you to stay safe. Take care of yourself. Bundle up unless it's really hot. Okay. Thanks for coming, everyone. Bye-bye.